Hello friends, welcome to the Why Things channel. Today, we're taking a closer look at one of nature's most fascinating works of art. Why are snowflakes different from each other? These tiny crystals floating down from the sky are like jewels, each with a unique pattern. But how is it that no two snowflakes are alike? Is this the magic of nature or a scientific miracle? In this video, we'll discover how snowflakes are formed, the science behind their unique shapes, the effects of temperature and humidity, the chaotic dance of the atmosphere, and how nature creates its art. If you're ready, let's embark on this icy journey and unravel the magic of snowflakes. 1. The birth of snowflakes, the magic of crystallization. Why are snowflakes different from each other? The answer lies in how they are formed. Snowflakes begin when water vapor in the atmosphere condenses on a cold surface, a microscopic particle like a dust particle or pollen. Water molecules form hexagonal crystal structures thanks to hydrogen bonds. This hexagonal symmetry explains why snowflakes are often six-armed or star-shaped. But here's where the real magic begins. Each snowflake goes through a unique journey through the cloud. This journey takes place over a few minutes. As water vapor is added to the crystal, temperature, humidity, and air currents determine how it grows. For example, as a snowflake falls from a cloud to the ground, it passes through different temperature and humidity zones. Each zone changes the branching pattern of the crystal, like a painter's brushstrokes. Mathematically, two snowflakes crystallizing under the same conditions is as unlikely as the number of stars in the universe. This makes snowflakes as unique as nature's fingerprints. 2. Temperature and humidity, painters of snowflakes. Snowflakes are shaped like works of art, depending on the environmental conditions. Two main factors come into play: temperature and humidity. Temperature: in mild conditions, such as -2 degrees Celsius, snowflakes form simple hexagonal plates or flat stars. In colder conditions, such as -15 degrees Celsius, complex, branched structures, dendrites, emerge because cold air allows molecules to crystallize more slowly and regularly. At -30 degrees Celsius, we see simpler structures like needles or columns. Humidity: high humidity allows more water molecules to be added to the crystal, which creates more detailed and ornate patterns. At low humidity, crystals remain smaller and simpler. For example, snowflakes formed in a moist, cold cloud are famous for their classic, branched star shapes, the kind you see on postcards. In a very cold and dry environment, however, simpler, cylindrical crystals form. Scientists have classified snowflakes into more than 80 categories: stars, needles, columns, pillars, capped crystals, even bizarre shapes like spaceships. Each one is a picture of the conditions of the atmosphere at that moment. This diversity shows how creative nature is. 3. Chaos and uniqueness, dance of the atmosphere. But why is no two snowflakes alike? The secret lies in the chaotic nature of the atmosphere. Each snowflake follows a different path as it falls from the clouds to the ground. The temperature changes, humidity fluctuations, and air turbulence it encounters along the way constantly alter the growth pattern of the crystal. For example, a snowflake will develop a branched structure as it passes through a moist region of the cloud, but these branches will shrink if it enters a dry region immediately afterwards. These chaotic conditions allow each flake to tell a unique story. Scientifically, the probability of two snowflakes passing through the same conditions at the same time is even lower than the number of stars in a galaxy. However, snowflakes produced in the laboratory under the same temperature and humidity conditions can look similar. This shows that uniqueness depends on the complexity of the natural environment. In other words, each snowflake is a reflection of the mood of the atmosphere at that moment, a poem of nature. 4. Scientific practices and cultural magic. Snowflakes are not only beautiful, but also very valuable for science. Meteorologists analyze atmospheric conditions by studying the shapes of snow crystals. For example, branched dendrites indicate a moist and cold cloud, while needle-shaped crystals indicate a drier environment. This information improves weather prediction models and climate studies. NASA uses satellites and radars to understand the structure of snowflakes because snow is a critical part of the water cycle and global water supplies. Snowflakes even play a role in understanding the effects of climate change. Melting snow could raise sea levels. Culturally, snowflakes are seen as nature's art and have had a profound impact on humanity. In Japan, snowflakes symbolize purity, impermanence, and Zen philosophy, even inspiring mythological stories such as the Yukiana, Snow Woman. In the 19th century, the American Wilson Bentley was the first to photograph snowflakes with a microscope and introduced their beauty to the world, calling each one a work of art. His photographs transformed snowflakes from a scientific curiosity into a part of popular culture. Snowflakes fascinate humanity both scientifically and emotionally. Here is the story of the unique beauty of snowflakes. Each snowflake is shaped by the dance of water molecules and the brushstrokes of temperature and humidity. The chaotic nature of the atmosphere makes these tiny crystals as unique as nature's fingerprints. A scientific miracle and an artistic masterpiece, snowflakes remind us how creative nature is. How do you feel when you look at snowflakes? Share your favorite winter moment in the comments, we'll be curious to read it. If you like this video, don't forget to press the like button, subscribe to the channel and turn on the notification bell. See you in the next why question. Don't forget to go for a walk in the snow, maybe you'll catch the secret of a snowflake.